Four laws of thermodynamics describe the relationship between energy and work. They are fundamental principles in physics and chemistry governing the behavior of energy in all systems. First is we have zeroth law of thermodynamics. If two thermodynamic systems are each in thermal equilibrium with a third, they are in thermal equilibrium with each other. This law establishes the concept of temperature if two objects are separately found to be at the same temperature. As a third object, they must be the same temperature as each other. It's a foundational concept that allows the consistent temperature measurements. Second is we have first law of thermodynamics, law of conservation of energy. Energy cannot be created or destroyed, but only transferred or changed from one form to another. This law states that the total energy of an isolated system remains constant. Energy can be converted between different forms, kinetic, potential, and heat, but the total amount remains the same. For example, burning fuel converts our chemical energy into heat and light energy. Third is we have second law of thermodynamics. The total entropy of an isolated system can only increase over time or remain constant in ideal cases where the system is in steady state or undergoing a reversible process. Entropy is a measure of disorder or randomness in system. This law states that natural processes tend to proceed in a direction that increases the total entropy of the universe. For example, heat naturally flows from other object to a colder object, increasing the overall entropy. Reversible processes are theoretical idealization. In reality, a natural process are irreversible and lead to increase in entropy. Fourth is third law of thermodynamics. The entropy of a perfect crystal at absolute zero temperature is zero. Absolute zero is the lowest possible temperature. 0 Kelvin or negative 273.15 degrees Celsius at this temperature. All molecular motion ceases and the system perfectly ordered. Therefore, its entropy is zero. This law provides a baseline for measuring entropy. It's not important to note that achieving absolute zero is practically impossible. The laws of thermodynamics have wide-ranging application across various fields.